Hey folks, today we are going to discuss LeetCode problem number 236 and the problem name is lowest common ancestor of a binary tree. So in this problem, we are given a binary tree and P and Q nodes. There are two nodes that we have been given and we have to return the lowest common ancestor. So let's check what a lowest common ancestor means. So the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as its descendants. So let me give you an example. If our P node is of value 5 and Q node is of value 1, our lowest common ancestor in this case would be, since this is 5 and this is 1, so the lowest common ancestor would be this thing. So we have to return 3 in this case. So this is the whole idea of this problem. And there is also one more condition that we have been given. So let me highlight that. Yeah, so a node is a descendant to itself, so that's what he's mentioning. So what that means is, if we have a node, let's say 5, so and if a P value is 5 and Q value is, let's say, 4, then the lowest common ancestor to both these nodes is not going to be 3, it's going to be 5 itself. Since a node can be descendant to itself, we'll consider 5 as descendant to itself and we'll return 5 as our final answer. So this is going to be it. So how we are going to solve this problem? We are going to recursively traverse to both left and right subtrees of a given node. So let's say from here, like for P is equals to 5 and Q is equals to 1 nodes, we are going to traverse from root node, that is 3, so to left and right subtree. So once we have traversed through there, we'll check if our current node value is P or Q. So if we find either P or Q, then we'll simply return that node. So now from here I'll be returning 5 and from here I'll be returning 1, right? So if I see both my left and right subtrees to be a valid nodes, that is, like, here we are returning 5 and we are returning 1, so in such case our answer is going to be 3, right? So I'll return my current node at which I'm performing this recursion, right? So I'll return 3 as my final answer. So there might be another cases as well. Let me show you another example. Yeah, so in this case, so if I start traversing from my root node, I'm going to be 5. I'm going to the root node 5 and I'll be simply returning 5 as our answer for this, right? But if I traverse to the right, I don't see my Q value. I'll traverse even further and I don't see both of them. In both of these nodes I don't find my Q values. Then I'll traverse to the next level and I'll find null, so I'll simply return null from here, from both left and right. So at this stage I'll again return null, right? So here I'll be returning null. So since we are not getting valid nodes from left subtree and right subtree of our current node, we'll return that particular node which is valid. So in this case we have to return 5 as our answer, right? So we'll simply return 5 at this stage. So this is the idea that we are going to implement. So let me quickly write the code for it. So initially, if our current node is equals to null, or if our current node is equals to the P node, or the current node is equals to Q node, we'll simply return the current node. Otherwise we'll traverse through the left subtree of the current node, that is self dot lowest common ancestor of root dot left and P and Q, right? otherwise we are going to traverse on the right subtree of the current node, which is self dot lowest common ancestor of root dot right and p and q. So once we got both the left and right nodes, we'll check whether both of these nodes are valid or not. So if left and right, then we'll return the root node as we have just talked about. Otherwise, we'll return whichever node that is valid, right? So return left if left, else we'll return right. So this is it, guys. Let me give it a dry run. So it's working fine. Let me submit it. Yeah, it's working fine. So the time and space complexities of this solution would be order of n and order of n respectively. So because since we are traversing down the entire tree, it is going to take order of n time, and for the recursive stack we are going to have order of n space complexity. So that's it for this day, guys. So hope you liked it. If you like this video, please like it, comment it, subscribe to it. This would keep me motivating to make more such videos. Thank you.